Good afternoon, dear ladies and gentlemen. My name is Julia Gazlanger, and I'm the representative of ChemTeam, and I'm going to present you a dusty story. Here is the problem, and actually we should have found the way of how to determine if there is any dust in the room or not. Next slide, please. What is dust? Dust is actually small particles of organic or mineral origin, and they have such sizes, and the small particles of dust may contain harmful bacteria. They are not dangerous for our health, but they can cause allergic diseases. And it is very important for those people who have allergy to cope somehow with it and to remove all the dust if it is possible. Next slide, please. There are several methods existing of how to remove the dust, and the most widespread method of detection how much dust is there in the room is a kind of gravimetry. When you get a piece of some material which absorbs a bit dust, firstly you weigh it before you take the sample, and then after taking the sample, and that is how you know how much dust is there. But actually it is not very convenient, because you have to do lots of operation, and you also must bear in mind that that the moisture and humidity in the room really affects the gravimetric method. Then there are some methods also based on electric phenomena, but they require special equipment, and they can't be used by simple people who just need to check the absence of dust every day. And actually there are also systems with filters, but they also need special attitude. Next slide. We stated these properties of analysis. Actually, we have they were stated in the task that we should have qualitative or at least semi-quantitative detection of dust. Then the method of the detection must be cheap and fast, so that single people could use it. Then if we should detect low concentration of dust, because we already removed the dust as possible as we could. And the next, it is very important to make such devices to be available for non-specialists when we speak about the people who suffer from allergy. Everyone knows that today such things like glucometer are really widespread, and they help people with sugar diabetes to lead normal life and to control the level of sugar in blood. And actually, the principle of working is based on photometric or is based on electrical conductivity of blood. Actually, this method is available for all kinds of people, and it is really simple to use. And we thought of using the same symbol for detecting the dust. This method will be based on photocalorimetry, and we will have the following as the usual photocalorimeter. Next slide, please. And actually, what we do, this is an analogy to the stripes were used for the glucometers. Here we have transparent sticky material where the dust can absorb, and flexible plastic base, so that when we don't depend on the pledge source, so we can flex it as we want. And so it is. Can then be, next slide please, it can then be put into the special device which would analyze the optical density of the dust. Next slide please. In theory we may suppose that the optical density will correlate with the concentration of dust. And that's why we even may have semi-quantitative detection. For example, we may do several we may take different several samples from with known quantity of dust, and then standardize it and do approximate calculations using just real Lambert law. And the linear correlation will also simplify the method. And as for the wavelength that we should choose, it may vary and it depends on the color of the base sticky base that we use. Next slide, please. And we also thought of how much it may cost, and actually taking into account the fact that the principle of working of the device will not differ from ionometers very in a large extent. So they think that it may have the same cost. And so the dust meter, as I called it, may cost about 1,000 or 3,000 rubles. It also may vary all of the electronic which is inside. For example, we can change the sizes and so on. And actually, the stripes will cost about 8,000 or 800 or 1,000 rubles, or approximately like that. Next slide, please. And in conclusion, I think that this method it may become a really very simple solution for those people who suffer from allergy and who need to take control of dust in everyday life. Next slide. Thanks for your attention.
Thank you very much. Do you have any clarifying questions?
No, thanks. I don't have.
Okay, you have 1 minute to prepare. Okay, next question please for the speakers team for the solution and presentation. Your time is up. Please welcome our opponent. Let's welcome. You have 5 minutes.
Morning, ladies and gentlemen. I'm really glad to see all of you here, and I'm really glad to be here too. So we'll start to conclude some points of that proposed task. First, I'd like to say great thanks for the presentation. That was rather understandable, clear. I hope that I understood everything, but will conclude it further. Okay, I couldn't understand, unfortunately, the proportion between glycometer and your photometric method, what you proposed. Because the glucometer works on another method, there is a non-selective method that is inside this machine, and the photometer works in another rules, another formulas and practice. What about the photometer, what your method that you propose to use? What about relay scattering? The radius of the dust is not 1 millimeter or 0.1 millimeter as you told us, but 0.3 micrometer. It's really a lot less. So what about the proportion between radius of the particle and the wave length? Excuse me, please. Okay. Further, about the construction. I understand that some construction will be at the place, for example, at home, as a constant material. For example, it would be somewhere on a carpet or on the floor, it doesn't matter, but it would be on one place. And there some dust will appear and you will measure the concentration of dust only in one place. And it isn't possible, I think that it's not possible to measure the dust with that one method. And, for example, the concentration of the dust in different places of one room is really variable. For example, on that carpet, on the sofa, and on the table. It's right. What more? We had to propose a practical way, but due to the relay scattering, this method would be really expensive because of the money. So I think that this problem, unfortunately, wasn't solved at all. We couldn't use this method to determine the dust for allergics. Maybe it's possible to determine some amount of the dust, but the allergetics people, it really used to be very accurate, very precise method to be suggested in that one solution. So I hope that maybe you can tell me some numbers of accuracy or precision, or maybe someone else. I hope that we'll talk about it later, but unfortunately now I think that that solution wasn't solved at all. Thank you.
I'll start with the very beginning. You asked me that this method is unselective and how it's correlated with the actual method of glucometry. Actually, they are connected just in the principle of working. As far as I remember, photometric way of using glucometers is based on the fact that when the light comes through the blood and it detects the level of sugar influence on the color of the blood. And that's why when the light penetrates in the blood, we may detect the differences, and that is how it is actually detected. The same holds true for us when light comes through our from our stripe, and then we need to go to the detector, and we again detect how much light has dispersed. Then actually about laser scattering, we use not the principle of actual photometry. We use a method when on the stripe is put several kinds of dust. Then we put it to our device. The light goes through this stripe, and actually because there are several dust there, the light just penetrates through it node, and that is how we detect the difference. Then thirdly, the construction. Actually, the construction is very easy. You asked me how we could measure the level of dust in different parts of the room. Using such stripes, they are really very small, so you can go just here, there, and there using 3 stripes. And like in the perimeter, when they are really small, you can get several samples from different parts of the room, and that is how you detect. And then finally, I don't think that it will be very expensive because because of the simplicity of the material that we use. Thank you. That's all.
Thank you very much. Now moving on to the most interesting part of the So you can start now.
Thank you a lot for your answers, but maybe I don't understand right, but what is our blood? What the color of our blood depends on?
On
On the sugar? On the amount of sugar?
No, it doesn't depend on sugar, but actually maybe the presence of sugar somehow depends, somehow influence on the color of blood. But I personally believe that it doesn't connect it any way to the solution of my problem, actually.
Okay, maybe I should something that was only interested for me about the glucometer. Maybe I need something else. Okay, what is the striped material?
We thought that the first 2 parts which are not transparent, they can be made by simple plastic, and the transparent part is something like the sticky substance I use in simple scotch. And that is just how it works. If you ask me, if you tell me that it may somehow influence on the light penetrating, we can take it into account before using that and make this amendment just before the device is sold.
Okay, but I told you that the size of this dust is about 0.3 micrometers, and do you think that scotch will be applicable to take all of that?
I haven't said that it was actually scotch. I just said that it uses the principle that works like scotch. And we can vary the different materials for that. And actually the size of dust, it really varies. When people suffer from such diseases like atopic dermatitis, they just have the dust from their skin, and the parts of their skin, they are really very weak compared to the other parts of dust. And actually, when you put your stripe onto your table or some other surfaces, you just some of the parts, they absorbs to this material, and then you put it to the device, and then you can detect just due to the light penetration.
Generally, there are some other methods that could be proposed to detect dust, but my question is that the allergic people who have allergy on dust, it may arise from, for example, you know that the dust consists of several parts of different types of dust, yeah? And one people may have allergy on one type of dust, and another man can have allergy to other to the third type of dust. And we have to detect the allergenic dust. Maybe it could be provided some biological method, but not physical one.
As far as I remember, it wasn't written in the text that we should define exactly the allergic kind of dust. We just should have proposed a method of detecting the dust which is universal. We may have dust from our skin or from small pieces of sand, anything, and this method works for everything.
Sorry, excuse me, please. There was several sentences about the allergy on the dust, and after that was written find out the practical way to detect domestic dust on surfaces, which would help to solve the problem of allergy on the dust. So, should we define only dust, or should we define allergy dust?
Actually, it can be, this question should be addressed to the authors and defend the meaning of the word which. We can just address this word to which may help, which could help solve. Oh, sorry, there is problem. As far as I remember, which could help solve this problem. It is addressed to the word practical way, which could help. And we don't know that actually the meaning of this sentence is that we must detect exactly a logical type of dust. That is just said that that this method that we propose might help and it might help. That is just
different ways to understand this task. I understood. Okay, the method, for example, maybe we can prove your method better. For example, we can buy one these type photometric system, for example, for several rooms. It would be less expensive because I think that it would be expensive or more than the cost on your.
Yes, have you ever seen a decorator?
Yes,
it is a small pieces of equipment, technical equipment, and actually we try the size of our device same as the glucometer, and that's why you don't need to carry all the photometric system on the trolley throughout all the room. You just may go to. You even just don't need to carry all the system. You just have stripes, go throughout all the threads, and then.
I'm not talking about the size of the system. I think that it would be expensive. I think, and you cannot prove me that it wouldn't, because I think that I think that the size of the particles this method would be precise to determine these little size of particles. So we have to buy some other system, and it would be expensive. So my question is, maybe that would be better to buy this system for several rooms, for example, families, and to combine the money and use it, for example, for all the house.
Let me at least try to make you believe me, but I just think that we will have the device similar actually to the glucometer. The normal price of the glucometer rise even from 800 rubles to 3,000 rubles, but it is it is even a more difficult device. We don't need such accuracy. It was written in the task that we should just decide determine if we have just dust or we don't have dust.
But maybe one more question. I will need the answer on that. What is the accuracy of that method?
Sorry.
Oh, okay.
Our experts say whether if she could ask a final question. Yeah. Thank you very much for the presentation. Challenges because they talk a lot about the problems, about the questions, and they usually go to the first part where there is the task and try to discuss the task. It's very good. Sometimes it's very hard to find the right word for this conditional question. Sentences. Thank you very much. Now I would like to ask the reviewer to give evaluation.
Good morning, my name is Igor. I'm from Full State University, and now I'm going to review this problem. First of all, I want to thank the board of good presentation and good explaining principle of the work. We can see good knowledge and good understanding of this problem by reporter and by opponents. I want to say that opponents asked a good question about construction of this device and about precision of this method. But opponents asked about principle of coping repository. I think that it doesn't matter because we should discuss only solution which was suggested by reporter. We can see a good polemics. So many questions has been discussed, but I have also some questions to reporter. What about sensitive of matter? And I have one question the same. What about calibration? If we measure exact concentration, I think that we need any calibration of this device because we use spectral photometric device, and I think that we need calibration. My review.
Thank you very much. Let's go to the reviewer. Now all of you have 5 minutes to discuss all your questions.
Let's see, let's start. Actually, about sensitivity, as you asked me, we were supposed to just propose a method that expresses if the dust, if there is a dust or there isn't dust. And that's why I just mentioned about semi-quantitative analysis, just because it really might work in this situation. But the main aim of what has been represented here is to detect whether there is any dust or there isn't. And about calibration, the calibration is just simple. If such kind of device is produced in any of plant, we may have the calibration which will include the optical density of the stripe with the transparent material inside, and maybe it may include anyhow the outer features. But when we speak about the calibration of known concentration, we can produce some dust artificially with the known size and known properties, and just like the voice that we can take into account to make the linear correlation, because using the law of Lambert-Weir, as it has been as it showed on the slide, then we will have the linear correlation.
How will you know the number of dust which we produce to calculate?
Actually,
That is a circle as far as I'm concerned.
Actually, I think that there has been lots of research on this theme, and their research that have already been done may lie into the base of this method. Just know.
But you don't want to mention which one of the method.
Actually, I don't think that it's important.
I asked this question because I saw this equation. It's the equation of Lambert Weir law, and this equation used for exact measurement. Because I asked this question about calibration. If you detect if there is dust at the surface or there is no dust at the surface, I think that this equation is necessary.
Let me repeat that I've already said. Actually, this method is qualitative, and we just have the opportunity to spread it on semi-quantitative. That is just the way how if we want to extend the abilities of our device. But this is not the main aim, that is just a probability. Why I use that equation? Actually, as I've already said, that is approximately evaluation of the level of dust. And we may think that anyway, what we do, we may take the concentration here in this equation as a model and measure the same things as we usually do in the calorimeter, photocalorimeter, and then just take it as their concentration.
Okay, but if you want to detect the dust, if there is dust or no, what is the problem only to use black material and to see?
Actually, that is...
if you do not have any accuracy, any...
I see.
More simple
I
device.
it's more simple than our eyes?
Device. More simple device.
Yes,
Can be
more
used
simple
for this.
device than our eyes.
Yes.
Actually, the ChemTeam phone is the simplest device people ever imagined. And that is device just may include some other functions. Not only just we come and make a measurement and see that there is dust or there isn't.
Sorry for a moment of time. Thank you very much for the polemics. Dear experts, I think you have not less than 16 questions. Yeah.
I have several questions. The first to the speaker. In your review of the existing methods, you have mentioned gravimetry as one of the methods of it is usually applied to solve this problem. Well, what should be the precision of the balances?
Well, actually, I didn't pay too much attention to this problem because because the method that I used it wasn't anyhow related to gravimetry.
Because you just have written the most widespread method is gravimetry. If the amount of dust is small and the weight of your object is very big, you can't determine it by this method.
Of course, we should somehow take it into account, but we use weights which have a really high resolution, and we also must take into account that these weights are not able to, for example, weight 1 kilo and so on.
Because if you look for the text of the problem, it was mentioned that you should determine the amount of dust on the walls in the room and so on. And of course this method is not suitable to solve that problem. The next question concerns your method. At first, once again, if we should look to this text, we can see that, for example, toys. If you will cut the third toy by a sticky strip, I'm afraid that not only the dust but also the fibers from the toys will be absorbed to the surface. How will you solve this problem?
We may modify just these sticky materials so that it would absorb on the dust and can absorb just the particles of known properties. But I think that we shouldn't cool it too much to the toy, just should somehow to put it there and then just move away.
And the last question concerns your solution. You have written that the wavelength at which you will measure the optical density depends on the color of the particles. So, as I understand, we should have the opportunity to tune the wavelength during the measurements. Is it possible to work at one wavelength only? And that will diminish the price significantly, I guess.
Actually, I think that the wavelength is not the main parameter that we should control, because even in photocalorimeters we actually may is dust of the reasons, the accuracy may be a bit
Okay, and the last question is that we have suggested to measure the intensity of the light passed through the sample. Why not the intensity of the scattered light?
Actually, it may also just be kind of suggestion, and this method was just a proposal that it might work, and of course it can be further modification. We actually don't know which of the light is easier to detect and better to detect.
Okay, but as to the accuracy of the measurements, for the fast light or for the scattered light, it should be higher for the dust particles. What is your opinion?
I think that maybe the fast light is easier to detect in such kind of devices because you just have the receiver, the source of light which pass through. But if we use a scatter light, it may reflect to any of the directions, and it is difficult to build such a detector that would consider every kind of light.
Thank you.
The last short question.
You just show me slide number 11. I assume that the price is not for one stripe, it's for the pack of stripes. How many stripes are there in the pack? These exactly stripes are 15. Oh, 50, sorry. 50, yeah, sorry. 50 stripes.
All right.
But their kits, they vary, so you can buy 100 stripes and so on. It depends just on the actually the producer.
And the next question is, can we use one stripe twice, thrice?
No,
Only once.
no, that's only once. The same as in the
To use it.
Okay, thank you very much. Sorry, we ran out. Let's welcome our dear speaker, opponent, and reviewer. You can now take the seats before the judges will decide how to score you. Thank you very much. Audience, please keep quiet and discuss everything on the break. My face smarts. Sorry. Wait some seconds.
Захожу, я думаю, нет, я я никогда
Okay, starting now. So, our dear experts are ready, and now we will announce the first score for the speakers team for this solution. 8, 6, 6, 5, 6, 7, 7, 6, 7, 8, 4, 4, 4, 8, 9. 10. Sorry, please wait. 8, 6.
We don't announce the numbers!
8, 6, 6, 5, 6, 7, 7, 6, 7, 8, 4, 4, 4. Because this is a lot of marks, so let's start again, yeah. 8, 6, 6, 5, 6, 7, 7, 6, 7, 8, 4, 4, 4, 8, 9, 10. Okay, thank you very much. Now the second score for the speakers team for the presentation. Please keep quiet because I can be wrong. 9, 7, 8, 8, 10, 9, 9, 7, 7, 8, 7, 7, 6, 7, 9, 9. The second time. 9, 7, 8, 8, 10, 9, 9, 7, 7, 8, 7, 7, 6, 7, 9, 9. Okay, thank you very much. And the third mark for the opposition is... Okay, thank you very much. 7, 8, 9, 7, 4, 7, 9, 7, 8, 6, 7, 7, 7, 7, 7, 7. And the second time, please. 7, 8, 9, 7, 4, 7, 9, 7, 8, 6, 7, 7, 7, 7, 7. Okay, thank you very much. And the other remarks we write in your basic way. Yeah? Thank you very much for the first chapter.